So, and now we are recording on YouTube also. It will be stored, the session would be stored on our YouTube channel. So, good evening and welcome. So, we'll be talking about soil fertility today, and I will start sharing my PPT. And our topic is essentially to understand what exactly builds fertility of the soil, what makes soil fertile. We'll understand the science of it. So, first thing I'm trying to convince you is that soil is the mother of all life. Actually, we say earth is the mother, but actually, within earth, it is soil who's the mother because it is really the bridge between the living and the dead, very literally so. Because if you see on top, you'll see life you'll see plants and animals, and of course, insects and bugs and bacteria and so on. And there's living soil on top. Just below plants, you have soil alive with life. And as you go down, at some depth, you have completely dead rock. And soil is the transition period between these two. I mean, it's like it actually brings back all the dead material back to life, gives birth to new life. We'll see how, but it is really the bridge. And actually, it's a very profound fact. How we treat our land determines how land treats us. This is true of all of human civilization. Even in history, like there were thriving civilizations which actually got ruined because they did not treat their soil properly or land properly. There were many reasons, but one primary reason was also bad treatment of the soil. It happened to Romans, it happened to Mesopotamians, and many other civilizations. So see, there we have these two words, soil and dirt. They have two different connotations. Dirt is not soil. In Hindi, we say dhool or mitti. So, when soil becomes dirt, it becomes lifeless. It becomes lifeless. It becomes incapable of giving birth to life. And here we are showing this from an ISRO survey. It was a random survey from satellite. How much of our soil, Indian soils, are getting desertified, converted to barren, lifeless soils. And there's a rough estimate that about 30% of India's total arable area, area where agriculture is can be done, is undergoing degradation, which means soil is becoming dirt. And this is true of much of the world also. I'll come to the reasons very soon, but it's a fact that soil has fed humanity for 10,000 years, actually more, but then 10,000 years is the time when agriculture came and we started sowing, we started agriculture. So soils were feeding us, and now the same soils have started dying. We'll see why. One reason is, of course, the soil getting eroded. So there is water and wind in erosion. Again, this figure is 33% of the Earth's surface, the upper surface, the thin upper surface. It's the skin. It's the skin of Earth that feeds everyone. If this skin is washed away, we lose a very, very precious resource. And already, I mean, security in the world is already threatened. So one third of the Earth's surface is degraded. Already, 1 in 7 people do not eat fully a full meal. And then malnutrition is visible in 2 to 3 people out of these 7 people. So our children, Indian children, are malnourished, but that's true of much of the world also. And all this is related. If we look at agriculture, I don't know how many of you are actually connected to directly to agriculture, but agriculture feeds all of us. So if we say that we are not agriculturists or agriculture is not our concern, agriculture brings food to our tables, to our plates. So farming today is becoming very risky and expensive. farmers have to do extra work. I mean, farming is not feeding the farming families enough, especially small farmers have to do extra work, which means they have to look for extra employment. So in cities, all the migrant labor we see are essentially farmers, and a whole lot of them, farmers, are in debt. We already know that farmer suicides happen in our country. So, how is it that land which used to feed everyone, farming which used to feed others also, firstly it must feed the farmer, the farming family, and then it must feed everybody else? How is it that farming is no longer remunerative? It's not feeding even the family who have the farm. So, farming is becoming just a supportive income, but not the main income. For main income, they come to cities and become laborers and rickshawalas and auto drivers and so on. So why? What has happened? What's gone wrong? Um, does anyone have an answer to this first before I move further? Can you answer this question?
मैम सवाल क्या है?
What has gone wrong that farming is not feeding everyone? मतलब क्या गड़बड़ हो गई कि फार्मिंग अब लोगों का पेट नहीं भर पा रही?
मैम
Can I try?
पॉपुलेशन
Yes, yes. Please
एक्सप्लोजन,
try.
पॉपुलेशन ज्यादा होती जा रही है और मैम लैंड पार्ट हमारे पास नहीं।
Okay, but then India always was a very heavily populated region. Our population was always high. Uh, Rihanna is saying because of pollution. Any other answer?
I think it is because food is being produced in factories now.
Okay, so
The
Neha is saying food is being produced in factories. Any other reason?
मैम क्योंकि जो सॉइल है वो उसकी फर्टिलिटी कम होती जा रही है।
Okay, Smriti is saying soil की fertility कम होती जा रही है. निगत कह रही हैं more fertilizer use. Any other answer? Just asking, how many of you are directly linked to agriculture, farming, horticulture, gardening? Somebody from chemistry learners is saying not fulfilling needs, expenses are more. Menika is saying switch over because according to their never be rewarded as money as well as respect. Okay, so she's saying farmers are switching over from farming because they don't get money, they don't have respect either. Any other answer?
Then before seeds are produced from the farmer, but now they buy it from others every year, and they use fertilizer and other things which is very costly, and nobody concerned about farmers.
See, anyone, if you want to answer in Hindi, you're most welcome. Bulbul is saying because seeds have to be purchased and a lot of farming inputs have to be purchased. Earlier, farmers used to produce their own seed. Imagine, doesn't it look very strange that a farmer to buy the next crop, sorry, to sow the next crop, has to buy seed? Farmer cannot produce his or her own seed. It's very strange. It is unheard of in the history of agriculture. Farmers produced seeds and they produced extra seeds. Some were used for the next crop, others were eaten by them, eaten by others. Smriti, any other answer? And they're saying overuse of fertilizer causes the degradation of soil fertility.
मैम पहले मीन्स थोड़ा लोकलाइज चीजें हुआ करती थी, उससे हम शिफ्ट कर गए हैं कि अब जो मोनोकल्चर की तरफ शिफ्ट कर गए हैं, शायद ये भी वजह है। तो जो सॉइल की मतलब जैसे मान लीजिए पंजाब की तरफ जो जहाँ पे धान नहीं होती थी वहां पे धान कर रहे हैं, और जो मिलेट्स थे, मान लीजिए कोई ड्राई जो जहाँ की जैसी लोकल रिक्वायरमेंट होती थी वैसी ही खेती हुआ करती थी। और वैसी होती थी, लेकिन अभी सबको गेहूं चावल पर हम शिफ्ट कर गए हैं, शायद ये एक रीजन हो सकता है क्या?
We'll talk about reasons. I have one question. I'm deliberately speaking in English. Does everyone here understand Hindi? Is there anyone who does not understand Hindi? Then I'll translate everything. Otherwise, we'll carry on in a mixed kind of language. Does everyone understand Hindi? Please say yes or no on the chat box. Especially if okay, so Amla Devi is saying no. So even if there is one person who doesn't understand, then we'll carry on in English. Right? But those who have difficulty speaking in English, you can speak in Hindi and I'll translate. Right? So okay. Okay, let's carry on. I mean, I do such sessions in Hindi as well. So, I mean, you can attend later also if English is a problem. So anyway, we'll see what's going wrong. Now we grow food only for quantity and only for the price it gets in the market. And this is a trend which has actually come with the Green Revolution. Green Revolution taught us to go towards higher and higher yield. This happened across the world. And Green Revolution came with the advent of, with the coming of chemicals in agriculture. So chemicals means chemicals for fertilizer, chemicals also for pesticides and fungicides and weedicides, and then purchased hybrid seeds. So it was hybrid seeds plus chemicals used as fertilizers, basically NPK, DAP. You all must have heard all those, or some of you must be using, and then of course then pesticides. So it's like only quantity and only price. So the only thing now we bother about for the past 60, 70 years, the only thing the world bothers about is quantity. How much yield, how much crop, how many tons, how many quintals, that's all. And of course, how much it sells for. But two questions have become completely redundant. What is the quality of the food we get? And where is health in all this? Where is human health? Where is plant health? Where is animal health?
हो गया तुम्हारा? रात की भूख नहीं?
So now it's a very sad story that modern foods have nearly a third of micronutrients. I hope everyone understands what we mean by micronutrients. Micronutrients are like various kinds of minerals. See, food must have carbohydrates, proteins, and fats, but it must also have vitamins and various minerals like iron, magnesium, manganese, cobalt, zinc, and so on. So these the other ones, the vitamins and minerals, which are needed in very small quantities, but where they are vital for human health, not only human health, plant health, and health of the planet, everyone, they are now nearly 1/3 as compared to a century back. Since we have started growing the food in the modern methods, so-called modern methods or chemical methods, and here, I mean, this is I have taken from National Institute of Nutrition. So, I mean, I'm only asking you. I got this table. So this is 1937 to 1989 comparison. You can see iron, and look at iron in leafy vegetables. It's minus 25.6. So much drop in iron in terms of percentage. And milk and milk products is minus 70.3%. So, and there are others also. You can see iron has dropped quite a lot. Similarly, there are others like calcium and magnesium and all that. And vitamin C also, there is a lot of drop. So, carotene, there's a lot of drop. But I haven't so far. I mean, I have to search more for more data, which is more modern. Like this is still 1989. So, but from someone, there was a UK study which was more up to the modern times. And as compared to 1940, it says that today we need to eat meat double in quantity to get the same amount of micronutrients. double amount of meat, 3 times fruit, and 5 times the vegetable to get the same amount of micronutrients. And there is like mineral decline, copper decline by 76%, calcium by 46%, iron by 27%, and so on. I mean, like all these are in 27 kinds of vegetables on the left hand side and 10 kinds of meat. So there is so much reduction in the nutrition that we used to get. And of course, a lot of other crises are building up with our earth getting hotter, and we are all facing multiple crises today. Now, the case I'll be making today is that soil fertility is the solution to a lot of these environmental and economic crises facing us. Many environmental crises, the key to them, the actual solution lies in soil health. And that's why I really want you to go back from this session convinced that working on our soil is the solution. So I'll try. Fertile topsoil is actually more precious than gold. I mean, think of it, gold cannot feed our future generations. It cannot feed us even today. Nobody can eat gold. And it can't feed any of our future generations, however much we collect it. Eventually, it will be soil which will feed everyone. Food is what we need even more than gold. And like I was saying earlier, thriving civilizations crashed. This is like Mesopotamia, I mean, the area near Tigris and Euphrates rivers, near modern Iraq and nearby. So now that area looks like this, which was called the Fertile Crescent, which was historically the first region to develop agriculture, where lots and lots of plants were turned into crops, wild plants were turned into crops. And today it's like this because of soil degradation. And here's a statement by a very senior scientist. He's very famous, Dr. Ratan Lal. He's winner of the World Food Prize. He says a mere 2% increase in the organic carbon content of the planet's soil could offset 100% of all greenhouse gas emissions going into the atmosphere. I mean, I'll soon come to what he means by organic carbon content, but basically, we are all so worried about greenhouse gases, about carbon dioxide building up, and because of that, the earth heating up, and we are thinking of like electric cars and solar panels, and we like new batteries, lithium-ion batteries, and so on. So much technology being invented somehow to reduce carbon dioxide emissions, but soil is an answer to that. If we can increase soil organic carbon content by 2%. I'll take time in explaining this, but see, we have a solution. We have a very practical solution and a very benign solution which has only benefits, nothing harmful about it. I mean, even if you build solar cars, you'll have to manufacture cars. If you build this solar panels, you mine some minerals and you mine special materials and lithium ion batteries. Already there's talk of less lithium being available and so on. But if you work on soil, there is nothing that we lose. We only gain. Everyone only gains. So I'll build this whole story. First, you tell me, out of these three, which soil do you judge to be the most fertile and which the least fertile?
मैम ब्लैक जो सबसे ब्लैक है
One which is blackest and one which is lightest in color. Yes, correct. So yeah, we readily recognize that the fertile soil is dark in color. So what is it that makes it dark? Can you tell?
humus content.
Smriti is saying humus content. So yes, so if we think what makes healthy soil dark, it's humus content. So we'll come to what is humus. So it's actually making the soil not only dark, but it's making it porous and crumbly also. This look at the texture of this soil. It's like very porous. It's very light. crumbles easily. So humus is this black or dark brown colored material. This is the final material after decay, after organic matter which falls in the soil decays. So this is the final stage. I mean, if there's no real final stage, it keeps decaying for a very, very long time. But this this is what which makes the soil uh, porous and gives life to soil. And this is only a very precious thin layer. I mean, like usually it is like 4 inch to 1 feet. In very rare cases, it can be 2 to 3 feet, but mostly it's like 1 foot. So this is the 1 feet, 1 foot is the humus containing soil, and this is the soil which actually gives birth to all plants. And if there's erosion, this is the most this precious layer, life-giving soil. This is the one which gets washed away. The most valuable part gets washed away very easily. So how is humus helpful for soil fertility? Can anyone tell?
मैम इसका वाटर रिटेंशन पावर बहुत होता है और थोड़ी पोरस होती है, तो एयर को भी पास होने में अच्छा रहता है। और
But what is
न्यूट्रिएंट्स
needful?
भी न्यूट्रिएंट्स
What
भी उसके न्यूट्रिएंट्स भी मिलते हैं उसको, और एक्स्ट्रा जो ह्यूमस से मिलते हैं।
Okay, any other answer? Firstly, then my question would be, why do we need air in soil? Air is above. Why do we need it in soil?
For the nitrogen fixation, ma'am.
For nitrogen fixation. Any other answer?
मैम और भी सपोर्टिंग माइक्रोब्स रहते हैं तो उनके लिए भी चाहिए होते हैं, और भी कुछ लाइक अर्थवर्म जैसे कुछ और सपोर्टिंग क्रीचर्स होंगे, उनके लिए भी एयर अच्छा मिले तो अच्छा रहेगा।
Okay, so Smriti is saying that air would be good for other small creatures that live in the soil, and Anu said for nitrogen fixation. Is there any other answer?
Hello, ma'am. Myself, Dr. Pooja. So my answer would be it oxidizes the soil and allows the roots to take up the appropriate nutrients.
So you are talking about air allowing the soil to take nutrients. I mean the roots to take nutrients. You're talking about air, or you're talking about humus?
Where like it oxidizes the soil.
What oxidizes the soil?
Air.
Air.
Yeah.
Okay. And somebody from chemistry learners is saying to maintain soil temperature. Okay. The thing is, see, the first thing we must recognize is that roots are living. Roots is a living part. Smriti, your uh, so roots are living, plant roots are living, and therefore they need oxygen like any other living part of the plant, and animals like anybody else living, they need oxygen, and therefore roots need air as much as leaves and stems and all those need air. Roots need air. So firstly, soil must have air. So soil, if the soil is porous and allows air inside, then it allows healthy roots. If you flood your soil, even in your pots or anywhere, some of you must be doing some gardening. If you flood it with water continuously, the roots rot. So the first thing is air is needed for roots. As far as oxidizing is concerned, that's not really correct. I mean, we don't need roots to be oxidized or even nutrients to be oxidized. Oxygen is needed for living, for life. So, but there are some other reasons have been mentioned why humus is helpful. So, like we said, it makes soil crumbly and porous. So crumbly and porous also allows roots to grow easily inside. And also, yes, of course, it allows many other living creatures to live in the soil. It increases water retention. Think of clay soils. Have you seen clay? It cannot hold much water. Actually, water doesn't even seep in. So if the soil becomes crumbly and porous, it holds more water, a greater amount of water goes down, it increases seepage. Humus is a long-term storehouse of nutrients. Plants do not eat humus. They cannot take in humus. Humus remains in the soil, but humus attaches nutrients to itself. Especially, I mean, some of you are chemistry teachers, so it attaches cations to itself, which means calcium, magnesium, and all those positive ions. It attaches to itself, and those are then taken up by roots. So humus acts like a storehouse of nutrients. It's not eaten directly. In fact, this was one reason for neglect of humus for nearly 100 years, because soil scientists thought that humus is not soluble, it's not water soluble. So they thought plants do not absorb it. And since they thought they don't absorb it, they thought humus is not of much value to plants. But now it is understood that it acts as a storehouse, plus it gives the soil the correct texture. Texture is very important. So it gives texture, and it gives this stable fertility. So humus containing soil remains fertile for long because humus attaches many ions to itself, mineral ions. And porosity, like I was saying, helps, like in porous soil, water goes down, air goes down, whereas this doesn't happen in compacted soil which have too much clay. So, and adding humus makes even clay better. So the texture of the soil improves. Texture of any soil, even sand, clay, any soil, if you add humus, its texture improves. And therefore, that's why, I mean, a mixture of sand and clay is good, but only that mixture will not do. It must have humus. Now coming to this important idea called soil organic carbon. As of today, this idea is extremely, extremely, extremely important. Our farmers don't know about it. Most people do not give it any attention because it cannot be sold in the market. So we give attention to only those things which can be sold in the market. Companies advertise or promote those things which can be sold. This cannot be sold because soil organic carbon is what? All that which drops on the soil, which was once living, or which is currently living. So soil organic carbon is a sum total of all this. One is humus, then there is natural charcoal. Some natural charcoal is also generated because of this decay process. And then all the dead material, which means dead wood and dead grass and dead leaves and decaying material and whatever is living. So all the living creatures plus living roots, everything coming from organic sources. And since all this is carbon based, all life is carbon based, so all this is the soil organic carbon. So all the carbon which is coming from organic sources. There is soil inorganic carbon also, but we are not concerned about that. Currently, we are concerned with soil organic carbon content. It's extremely vital for soil fertility. And we'll show you why. But currently, what's happening is in most of our farms and fields and our gardens, the organic carbon content is very, very low. It's less than 0.5%, 0.3, 0.2, 0.5. 0.5 also is rare. It's less than 0.5. Though actual fertile soil, good soil needs at least 2 to 3%. For example, if you have a decent forest soil, then it will be 2 to 3%, like at least 6 to 8 times the current content. And very, very healthy soils can have even more, 5%, 6%, 7%, 8%. But that doesn't happen easily, rare, but at least 2 to 3% is needed. And because we have very little organic carbon content, a lot of damage is happening to the soil fertility, and the results of that are seen across the world in agriculture produce and crops. So here's a soil report card. You can see here, you can see this column is Uplabdh Jivansh carbon, which is available soil organic carbon. Percentage is 0.45, and the category is low. L means low. So this report card is given by all labs, but nobody knows. Okay, most people don't know what to do about it because there's nothing from the market that you can purchase easily and put and increase this organic carbon content. So how it will be built? Of course, by adding more of this, more of biomass or organic matter. But fertility is not only availability of this matter. Fertility is a interplay of three things. These three. On one side, there is organic matter, which means living creatures and their dead parts and their wastes. So all that, which is shown in this block. Then on the other hand, there are minerals, which is like, you can say this is rock powder or a powder of stones, which has like, okay, minerals like calcium, magnesium, calcium carbonate and oxides, carbonates, oxides, sulfides, and so on, of many minerals. So this is basically coming from rocks, and it has sulfur, phosphorus, etc. And then the third is these living creatures in the soil. There is a vast community of living beings in the soil. And these three factors or three actors in the soil actually interact with each other. They actually work with each other. The three work with each other to build soil fertility and to make soil actually fertile or capable of producing. So these become the three major determinants. I mean, we talked about carbon, but we will also see that nitrogen is another big determinant, and another big determinant of soil fertility is microbes. So we'll come to that. So firstly, talking about carbon, soil carbon. So you can say all this is soil carbon. I mean, these are carbon-rich materials. So leaves and grasses and even weeds and all the crop waste, all crop residues, prali or the stubble which is burnt these days, it's really a valuable material. It's valuable for the soil. And then, of course, dung, etc., all the in the animal waste. So all this is carbon-rich materials, essentially biomass of any kind, even our kitchen waste is good biomass. Kitchen waste, wood shavings, anything, any biomass is carbon rich, generally carbon rich. And nitrogen rich materials normally are animal wastes, particularly urine. There is some nitrogen even in dung, but not so much as urine. So this is the natural availability of nitrogen, but there are, of course, other sources. So the thing is that soil needs carbon in huge quantities, like 2 to 3% by weight. Huge quantities of carbon is needed, and in a jungle, in natural surroundings, all the time trees keep dropping leaves and dead wood, and all animals keep dropping their wastes, and like animals keep dying. So there's enough dead or decaying material to supply this carbon. It's extremely vital for soil health. But these days we have learned to burn our stubble, to remove crop wastes. Crop wastes are not put back into the soil. Leaves are swept away. So even in gardens, we see leaves as dirty and we just sweep them away. So the essential carbon which should have gone back to the soil doesn't go there. And then the second thing which is very important is nitrogen. So the world realized the importance of nitrogen very soon, and now we have started adding nitrogen artificially. I'll come to what damage it does, but you can see that this carbon nitrogen ratio is important. I mean, carbon should be at least 20 to 30 times that of nitrogen. So if you put too much nitrogen, like we do these days, we put urea and we put DAP, and we do not put enough carbon, then it does damage. But suppose you put no nitrogen and you put only carbon alone, that will also make compromise your soil fertility. So both are important, and this is like roughly in tropics, carbon should be 20-30 times, which means lots of it. I mean, nobody is going to measure it like this, but you need lots and lots of carbon, and you need some nitrogen. Then we come to this very important fact. Just look at this. A teaspoon of healthy soil contains 1 billion living creatures. 1 billion. It's actually, soil is teeming with life. It's alive with life. To see soil as dead is one of the biggest mistakes we have done over the past 1 century, when we thought we could build soil fertility. So we put in so much chemicals, we put NPK, we put this, we put that, but we did not see what lived inside the soil. Actually, I mean, other than a few scientists, many scientists thought whatever lived in the soil was just like that. I mean, they were doing nothing. They were doing nothing of consequence to us. They were doing nothing of consequence to crops. And that was the biggest mistake of the past century. Good soil is alive with life, and it is soil biology which decides everything, including growth, including health, and including production, including crops, and even micronutrient availability. So so first we look at these soil creatures. There are like bacteria, fungi, lot of micro, macro, some big, some small, loads of them, very large variety, 10,000 of them at least, 10,000 varieties. They live inside the soil. And here is a video also showing some under a microscope. So I'll show a few. You will see so you can see protozoa here, others, there are nematodes, worms of various kinds, a lot of soil life, lots of it. So, I mean, of course, biologists would study all this, but there's a full-fledged ecosystem existing inside the soil, a very complex and rich, and in fact, very, very little has been studied so far. Only 1% of soil organisms are actually known. Firstly, because they are not uniform. I mean, like soil in one place and soil in another place will not have the same creatures. So it's very hard studying them. But an important fact is that there is this region surrounding the soils, which is called the rhizosphere. You can see it has a different color. It looks different. At least in this photo, it's looking different. Sometimes we can see, sometimes we cannot, but there's this region is very important. Why it's important? Because it is full of microbial colonies. Bacteria and fungi are crowding here, particularly bacteria. There's a huge crowd of bacteria, 50 to 100 times more than rest of the soil near the roots. So what are the bacteria doing there? And what are fungi doing there? That is the question. That is the question which has been studied and understood in past 20-30 years. So here, I mean, I have this beautiful picture. This is an aquarium of a friend. And in this aquarium, these are actual plants growing in the soil. And can you see the roots? Look at the roots. Around the roots, you see these orange regions, which are actually bacterial colonies. So bacteria are making their colonies all around the roots and giving some very, very vital services. So, and then come fungi, many varieties of fungi. So fungal threads are actually around roots, between soil particles. There's a vast network, vast and very rich network. It was known earlier, but its function was not known. Its function was not known. It's only now that we have started realizing what are they doing. They are called mycorrhiza or mycorrhiza. So mycorrhiza is fungal threads. And the interesting thing is, we used to think earlier that roots only absorb materials. So we thought roots are there to absorb water and minerals and so on for the plant. But it's now that we know, this is a photograph under a microscope. The roots give out secretions. And not only small amount, vast quantities of secretions. This is food. This is glucose, this is amino acids, and this is given out to feed bacteria and fungi. These are called root exudates. So which means roots are actively feeding or keeping bacteria and fungi well fed and thriving and colonizing around them. So plants are actually almost, the way we keep pets, plants are keeping these as pets, bacteria and fungi. They are colonizing these around themselves, the plant roots. So the way plants had learned to make symbiotic relationship with pollinators and seed dispersal agents above the ground, below the ground, they made symbiotic relationships with bacteria and fungi. And these are very, very vital for plants, and plants spend quite a lot of energy on them. This secretions are nearly 1/3 of the total food produced by the plant. By photosynthesis, if plant produces whatever glucose it produces, 1/3 it feeds to these bacteria and fungi. Just imagine, 1/3 of its production. So these must be giving some very, very vital services. Here we see fungal threads between soil particles. So soil particles are essentially linked together, networked, and even plants are linked together by these fungal threads. And actually, it is these soil organisms which are the real farmers. They grow healthy plants. I mean, we think in our arrogance that we are growing plants and we are supplying them nutrients. It is soil organisms which are doing this. So how are these keeping soil healthy? Let's see. Firstly, okay, fungal threads we hated fungi in the past because we had only seen fungal diseases. Even in plants, we had seen fungal diseases. In animals and other places, even humans, we knew of fungal diseases. So we thought of them as enemies. Now we know that only 5% are enemies. 95% are friends, and very important friends, giving very vital services. So one thing they do is increase root surface area. So here's a root here. Look at the fungal threads around, increasing surface area 10 times, because of which nutrient absorption itself becomes 2 to 3 times. Because plant has limited root capacity, the root has a limited region in which it can go. So fungal threads increase this capacity to a very, very large area. So that is the first service they give. Bacteria, on the other hand, create a protective sheath around roots. So this is called rhizosheath. And this sheath gives another service. Can you guess what service it could be giving?
या मैम क्या पूछा आपने?
ये बैक्टीरिया की कवरिंग है, रूट्स को कवर कर रखा है बैक्टीरिया ने, शीथ बना रखी है, मतलब कवच बना रखा है. तो ये बैक्टीरिया क्या मदद कर रहे होंगे रूट्स? व्हाट हेल्प दे मस्ट बी गिवन?
डायरेक्ट सनलाइट से कुछ नुकसान हो सकता है उसको, तो
But roots are never in direct sunlight. ये तो उखाड़ के दिखा रहे हैं, but roots are not in sunlight. Roots are under the okay. So Kavya is saying nitrogen fixing. Okay, that is, yes, okay. One service that bacteria give, they fix nitrogen. Some of them, not all, but yes, that's one. So they convert atmospheric nitrogen to usable form Menika has written nitrates, nitrites. Menika, can you explain? So Menika is probably not hearing. So so Rakesh Verma is saying nutrition gather. Yes, so it is these bacteria which allow a lot of nutrition present in the soil to make it in a soluble form and give it to plants. They provide, they firstly make many molecules more soluble, simpler forms so that they can be absorbed by the roots. So they provide the soluble forms. That's one service. And like Nighat Akhtar is saying, converting atmospheric nitrogen in simple forms. Yes, direct nitrogen cannot be absorbed, so they convert it into nitrates and nitrites. So Menika is also saying rhizobium bacteria converts nitrites and nitrates from nitrogen. Yes, correct. So it's not only, of course, they provide nitrogen, but nitrogen is not the only substance they provide to roots. There are many other substances which bacteria make soluble. So they convert it into soluble form so that the roots can absorb them. So that's one service. The other very important service is that they they create a protective layer. So these are friendly bacteria. So roots actually know which bacteria can come near them. Only their friend bacteria can crowd around. There are special chemical messengers for friendly bacteria. So roots invite them to surround themselves so that enemy bacteria cannot come. Disease causing pathogens or enemy bacteria cannot come. So this is protection. A similar protection actually exists in our own intestines also. Our intestines are also coated with friendly bacteria, particularly our large intestine. And yes, this is a symbiotic relationship. So bacteria protect from disease. They protect plant roots also. They protect our intestines also. From disease causing agents, they protect from disease. So that's the second big service they provide. So these are of course the famous rhizobium bacteria. We see them in methi roots and in leguminous plants, pulses and all those. So bacteria, these are rhizobium nodules. They provide they convert atmospheric nitrogen gas into soluble nitrates and nitrites. Other than that, they also make phosphorus and other nutrients available to plants. So that's one big service bacteria provide. Here there is a animated video animation to show the same thing happening. So so the video is saying that plants they can't move, and there's a large amount of unreachable area. And also the root and root hair are not so thick that they can penetrate the soil particles. I mean, like the spaces between soil particles are very tiny. So they are 0.2 millimeters. So the root cannot go there. So roots, of course, grow amidst soil, and they grow root hair. But after that, these roots take the help of bacteria and fungi. So here is a root tip shown here, and there is a full layer in which bacteria are residing, and these bacteria are providing the root with potassium and phosphorus. This is the layer of bacteria. So this is the rhizosphere, where so calcium, potassium, magnesium, phosphorus. So all the nutrients which are vital for plants, the bacteria are making them soluble and available. So that's the one service they are providing. Then the other service is provided by fungus, and which is for the unreachable area. So the mycorrhiza or the fungal threads, They are very tiny, microscopic. We can't see them with our eyes, but they surround root hair and root branches. So, I mean, the animation will show. So, in the unreachable area, these fungal threads will, here it's saying that these were known earlier in olden times, but their function was not known. So, here it's showing that there is there's root and there's these fungal threads going into the roots. Actually, they enter the root cells. They enter root cells on one side and then enter the soil, the spaces between soil particles, which is what this animation is showing. So here is a root, and this is the root tip. The space between soil particles cannot be reached by this root, so that space is now, and where water and other minerals are lying. So that space is now colonized by mycorrhizal fungi, and they spread around in this region, and they pull all the minerals and water and take it to the plant root. So this is the vital service for which the plant is feeding them. The plant is actually feeding them. That I'll give you glucose and you give me these valuable minerals. So its own network becomes vast. And it's not only that they are serving a single plant, they are helping plant to plant communication also. So these days it's called Wood Wide Web, WWW, Wood Wide Web. Plant to plant communication. In fact, a mother plant feeds its baby plants using this network. If you, I mean, all this is not there in this video, so I'll. So, I mean, if you cut a tree and the stump is left, you see that after some time, the new leaves come from the stump because the nearby trees will feed that tree with the help of these fungal network. So plants actually communicate to each other, help each other with this fungal network, and there's a lot of cooperation and community between plants, something which humans did not know historically, but is realized now. So here, so I mean, okay, first, is there a question so far before I proceed?
मैम जो कंपेनियन गार्डनिंग जिसे बोलते हैं कि कुछ मिक्स करके लगाते हैं, वो भी मतलब एक दूसरे से कमी होती है तो एक दूसरे को सपोर्ट करते हैं, वो भी इसी तरीके के बैक्टीरियाज के थ्रू होता होगा?
Fungal threads, not bacteria, fungal threads. So these are
fungal
thread, fungal threads. So they, like many plants do depend upon their nearby plants. I mean, which ones depend on which ones is not something I will know. I mean, this will only be known by botanists. But it's true that I have heard that some trees just cannot live alone. They have to be in their communities. For example, I've heard that of sal trees. That sal trees will die if you leave a sal tree alone. It needs its community. So they have a community network, they have community exchange, and that talk, this conversation, that conversation is mostly chemical messages that happens only through these roots, and roots connected through fungal networks. So it has a lot of role in keeping plants connected to each other. Even whenever there's some danger, some insect attacks or disease attacks, plants build their defenses. They build chemical defenses, and for that also they inform each other. So that's also well known that plants actually send messages to each other. So is there any other question or comment before I proceed? I need a 2-3 minutes bio break. So can we take a break? I'll just pause recording. I don't think I can pause the recording. So the recording will go on, but I'll just come in 2 minutes. So I'm back and I have a comment by Minka, like phytohormones, any special name for chemical messages? I won't know, Minka. I mean, if there is any special name for these chemical messages. You see, I'm
I'm
a
training, ma'am. Already we
non
also studied the phytohormones now, ma'am, as in given names. So like that, I'm asking any chemical messenger's name is there.
No, I won't know. I won't know. See, like, well, I'm a non-biologist, non-botanist. I'm only okay. I'm just studying environmental science only because it's become so vital for all science people to understand it. It's like today, environmental science, ecology should be the mother of all sciences. All of us should actually submit to what ecology is telling us. If we don't do that, we'll be destroyed. Yeah.
Thank you. Thank you.
Any other comment? And science, if understood correctly, can be very, very empowering. Particularly when we have reached a stage when we are destroying the world, we are destroying ourselves actually and our living basis. So we should understand the correct science or what we are doing wrongly and how we can correct it. So here is a very interesting experiment. This was done in 1902 by a German named Lorenz Hiltner. He was, so you see, even like more than 100 years back, some scientists had realized that microbes were playing some very, very vital role in soil. So what he did was he took two plots, and in one he killed all microbes, artificially killed all microbes, and then added a pathogen, which means a disease causing agent, deliberately. In the other one, he allowed all microbes to live. So identical soil was added to both plots, except that in one plot, all microbes were killed. In other, microbes were left as they were, and then in both, a pathogen, a disease-causing agent, was added. I mean, where I read this, it wasn't written what disease-causing agent it was. It could have been a fungus. It could be a bacteria. But what happened was, in the plot where microbes were left as such, the plant remained healthy. Whereas in the other plot where microbes had been artificially killed, the soil sterilized, there the plants became very sick and became totally diseased. So it was already shown, I mean, so far back, that microbes were protecting plants in some way. But what was the exact mechanism? It took another 125 years, I mean, okay, what, nearly 100 years to realize that. There's another very famous scientist called Albert Howard. He lived in India, he lived in Indore. Actually, there's an Indore model of compost farming. So he had
यस
also said
मैम, यहाँ
long,
पे एक एग्रीकल्चर कॉलेज है, तो वहां पर ये पूरा मॉडल था और वो काफी फेमस हुआ था। वो वाला मॉडल इंडो इंडो प्लांट बोलते थे उसको, शायद ऐसे कुछ इंडो पोस्ट, नहीं इंडो पोस्ट जो वहां पे जो बनाते थे वो उसको इंडो पोस्ट कहते थे।
Mhm. So he had also said 100 years back that
या
there's something very valuable these soil creatures were doing, microbes and fungi and all those. But the thing is, that time he couldn't tell exactly what they were doing. But he had warned that this chemical based agriculture is not going to be wise. He had already warned, his books are there, and they're like, I also have read one or two of his books. So he had already warned. But the world had gone on the path to greed, and the world wars had come. So it is actually World War One and World War Two which brought chemical based agriculture, because we had so much nitrate. Because we had here, there are many chemistry teachers here. That's why I'm saying there was Haber Bosch process. It came in World War One, which taught us how to convert atmospheric nitrogen into nitrate. This was to create bombs. But once those bombs were utilized in killing, then the next question was what do we do with this nitrates? So we built fertilizer. Similarly, poisons were invented to kill humans by Hitler's associates. There was one specific scientist who invented poisons to kill humans. But once wars ended, then what do we do with these poisons? Now kill pests. So that's how pesticides came. So it's actually wars which gave birth to the current model of agriculture. In a very crude sense, we can say so. But eventually, it's like our lack of full understanding of what was happening inside the soil. So the point here is, the point which I've been trying to make, I'm trying to show you is that why is soil organic carbon important? Because it maintains a healthy microbial community. It's because soil creatures thrive on that organic carbon. Either they are decaying the decaying leaves or grasses or stubble or whatever, so they are eating that, or they are the ones who are decomposers. So if you unless you add material which they can decompose and they can eat and they can thrive, your soil cannot be healthy, because soil cannot be fertile. It is kept fertile by these creatures, this thriving community. So that's why soil organic carbon is very, very important. It is a very important indicator of soil health. And this is the exact indicator which is very badly neglected today. I mean, most farmers do not know about, they don't know what to do with this, or what should be doing something about this. Even in organic farms, they don't know its importance. They do nothing about it. We all know about earthworms and the services they give. Just look at this. Earthworms create these casts. These are called casts. These little balls they make, soil nuggets they make. So in 1 year, earthworms, if the soil has a lot of earthworms, they give 25 tons of nutrient-rich casts per acre per year. 25 tons, which has 50% more humus, 5 times nitrogen, 7 times phosphate, and 11 times potassium. So much they give. And we kill them. They give such free services, they are giving free nutrients, and we kill them by adding chemicals. Whatever chemicals we add simply destroy earthworms. Of course, we know, all of us know, pesticide sprays kill 95% of beneficial organisms like pollinators. Already well known, and we know that without pollination, crops cannot thrive, cannot yield seeds, cannot yield fruits, and still we kill them. I mean, it's like, in a very strange way, we are doing a lot of things very, very wrong. and which will actually destroy our world even for future generations, not only for ourselves. You see, in nature, there is growth on one side, but constantly there's decay on the other side. So the decay builds new growth. It's like it's a completely cyclic process. New life, which leads to waste and death, and then that waste and death in soil gets converted back to new life. So it's like from death rises new life. So unless we put all this, whatever we take out from soil, we put it back into soil, no new material can grow. This is a very, very simple, this is simple math actually. I mean, if you see all micronutrients, micro and macro, calcium, carbon, phosphorus, hydrogen, potassium, oxygen, nitrogen, magnesium, zinc, whatever, lots of them. There are quite a few actually. Everything is recycled in the same soil. Every single nutrient is recycled if done properly. And it's these micronutrients in soil that make food tasty and healthy. And this whole thing is ensured by microbes only. I mean, it's if our modern foods, chemical fed foods, don't taste so well, taste so good, or they don't have enough nutrition, that's simply because there's not enough micronutrients. We have depleted the soil of micronutrients. If the soil doesn't have, how will plants have? If plants don't have, how will crops have? So it's a very simple thing to understand. And so far, any comment or question? Because I'm getting to a new idea.
तो मैम जो ये एलोपैथिक ट्रीटमेंट है एग्रीकल्चर में ये सबसे ज्यादा नुकसान वाला है.
What do you mean by allopathic treatment?
मीन्स कुछ भी बीमारी हो तो कुछ सबको एक जैसे ट्रीट कर दो डाल दो जैसे.
The chemicals that we put as pesticides, as insecticides, as fungicides, as weedicides, they are all harmful because they kill soil creatures. Basically, it's soil creatures which must live if we have to live. If plants have to live and we have to live, soil creatures must live. And all the sides, weedicide, fungicide, insecticide, pesticide, these are all poisons. So the first thing they will kill is they will kill soil creatures, soil micro flora, fauna, all that. It's called soil microbiota. So I mean, all those are killed. So if we kill all those, soil cannot be healthy, and therefore our food cannot be healthy. It's a very simple relationship. Once we understand that it's microbes, or rather creatures, soil creatures build fertility, once we know that, then the only thing we need to do is feed those. If they eat, we will eat.
और
It's
मैम
as
जो
simple as
इम्यूनिटी मतलब जैसे हमारी बॉडी की इम्यूनिटी होती है कि अगर हमारी गट हेल्थ अच्छी है तो हमारी इम्यूनिटी अच्छी है, वैसे आपने जो बताया कि प्लांट्स भी एक इम्यूनिटी अपनी डेवलप किए हुए रहते हैं. अगर उनके पास में माइक्रोब्स और अच्छे फंजाई जो होते हैं वो हैं तो वो उनके पास कोई पैथोजन आए तो वो उसको मैनेज कर लेते हैं.
absolutely. Plant immunity is essentially also just their friendly bacteria and friendly fungi giving them protection. It's really that. It's in our case, we also have blood with our immune cells and our complex immune system, but our immune system also in our body is also trained by our gut bacteria. This is also very strange realization. Swapna ma'am is here, our in-house biologist. So our immune system for a young child, for an infant, when he or she is born, the immune system is trained by the bacteria which reside in his or her intestines, or firstly from mother's bacteria go to the child, and then the bacteria start residing in the gut, which means intestines, and the immune system trains itself there. So, I mean, there have been scientists are funny people. I mean, there have been experiments where it was done with rats, of course, can't be done with humans, that all gut bacteria were killed in rats. They were sterilized. Their intestines were sterilized. Those rats became extremely ill. They did not grow. They became extremely ill because there was no bacteria to teach their immune system. So in our case, our immune system is taught by them. In plants, bacteria and fungi are giving direct protection. So there's a little difference, but they are giving direct protection by building that sheath, or that you can say that covering around the roots.
बट मैम जो गवर्नमेंट इंस्टीट्यूट्स में जो रिसर्च हो रही है, तो वो उसकी डायरेक्शन कुछ इसकी तरफ नहीं जा रही है कि हमारे क्योंकि गवर्नमेंट की तरफ से ही ऐसी सारी चीजें आएंगी तभी कुछ चीजें होंगी, क्योंकि अभी तो सारे जो किसान हैं, जो मतलब छोटी जमीनों वाले किसान होंगे, वो सरकार से ही सब कुछ सब्सिडी के थ्रू सब ले करके, सीड्स भी हो या फर्टिलाइजर्स हो.
You are right. See, government policy should stop promoting fertilizers and pesticides, but there's a huge lobby of corporates who are selling seeds, hybrid seeds, who are selling pesticides, who are selling fertilizers, and they'll not let government stop. So it's a it's a very complex story. I mean, have we been able to stop, for example, our supplements, vitamin supplements, mineral supplements, out of harmful things that we are sold as drugs? But let's not get there. But yes, government policy must change. But first we should also realize, see, science, you and I can also learn. And we can learn that what's happening is not correct, right? So currently, an ordinary citizen can save his or her farm if he or she realizes what's wrong. If even if government doesn't do anything, he or she can do. And that's why I think ordinary people should understand this. So anyway, coming back, there is this modern idea. This idea is quite new. No-till farming. No-till farming means no plowing, no plow. The farm should not be tilled or plowed. Can you tell me, I mean, the people who have been listening, can you tell me what harm plowing could do? I mean, if you have been hearing me all this while, so what can be the harm if we plow our soil, our field with tractors and with traditional plows?
जो टिलिंग होगी तो जो लूज मिट्टी हो जाती है, उससे जो बैक्टीरिया या जो फंजाई का जो कॉलोनीज होती हैं, वो एक्सपोज हो जाती हैं सनलाइट के, और शायद वो डिस्ट्रॉय हो जाती हैं थोड़ी सी, तो ये प्रॉब्लम होती होगी.
Okay. Smriti is saying plowing could be disturbing the fungal and microbial colonies. Kavya is saying microbes can be disturbed. Nigat is saying microorganisms destruction. Yeah. Any other thoughts on this? I mean, all of you are saying similar things, but any more ideas on this? So Menka is saying topsoil. Menka, what about topsoil? Erosion. Nigat is saying erosion. Yes. So there are everything that you people have said is correct. So one is that soil becomes, can you see what happens to soil? Firstly, it becomes exposed to sun. So first thing that happens is drying. All the water, all the moisture dries up. and organisms cannot live without water. So good soil or fertile soil is always moist. It need not be flooded with water, but it must be moist. There should be some little moisture. If we expose it directly to the sun, then the moisture goes, it dries up, and the in topsoil microbes die. So that is, so drying up is one process that happens. Second, like you said, that erosion might happen, that soil, I mean, if you dig up soil like this, wind erosion and water erosion, if suppose it rains so much, and a lot of water flows from here, it will take away a lot of precious topsoil. So wind, and of course this can like go away with the wind also, and so erosion can happen. And third, microbes will directly get exposed to sun, because of which they can die, and some amount of oxidation of soil carbon also happens. So it's like all these factors happen. Uh, but first, let me ask, why do we plow? What advantages does plowing give?
Hmm.
I've been doing it for 10,000 years now.
मैम सीड वगैरह डालने के लिए.
Okay, so one advantage is creating trenches for seeds. Any other?
Plowing,
So what is the advantage? Why do we plow?
to make soil loose.
So one,
For
yeah, so there
irrigation
are
also.
answers here also, to make the soil porous, to make soil loose, correct? And so that we can add seeds for aeration, for weeds removal. Yes, correct. So, I mean, all your answers are correct. This is how, that is why we plow. But one thing to notice is that nobody plows in a forest. Nobody plows in a forest, still a forest thrives.
बट
So
मैम
that
वहां पे हम जो गेहूं चावल जैसी फसलें नहीं करते ना, वो तो पेड़ करते हैं. तो पेड़ों के लिए तो बिना टिलिंग के छोटा सा एक सीड डाला, या मीन्स जो पत्तियां गिर रही होती हैं उसी से वो कवर हो जाता है. बट जो हम फार्मिंग करते हैं वो इतने बड़े लेवल पे कौन उसे कवर करेगा? मतलब या तो फिर मल्चिंग वगैरह करनी पड़ेगी, ऐसा कुछ करना पड़ेगा. सो
So, see, Smriti is saying that in a forest there are only trees, but that's not true. A forest is always a mixture of trees, grasses, shrubs, herbs. It is like all kinds of plants are there. In between trees, there are small plants also, and nobody tills or plows in a forest. So, and we do it for aeration, and for putting in seed, and of course, like you said, for removing weeds, and things like that. So the thing is, plowing, it's a modern realization. It's like this has been realized only in the past century, that plowing is doing much more damage than the benefit it is giving. It is giving some benefits, particularly on bad soil. For bad soil, you need plowing, but it is doing far more damage. So now some substitutes have come, and now no-till is slowly becoming fashionable, or adopted practice, that people will not till. And here there is another problem. If you are plowing with the help of a tractor, we need porous soil, we need loose soil, and the tractor is 5 ton. So just think of what it's doing to your soil. It will compact it again. It will dig, but it will also compact. So tractor is doing even more harm. Firstly, plowing is doing harm, but at least plowing with the help of these cattle, uh, it was not so bad as much as now the plowing with a tractor. So plowing opens the soil to drying, to erosion, and destruction of living creatures. So now there is this new idea of, and actually this new idea of no-till farming actually started in US, when they had, in 1930s, they had this huge, massive, uh, very, very frightening dust storms. All that dust, like miles high, and all that dust was coming from their own agriculture fields. They have huge agriculture fields, 1,000 acres, 500 acres, and so much loose soil was coming. Then the country realized that we are doing something very wrong, and they set up a department called soil conservation. So no-till is more prevalent in US than in our country. It's like I read somewhere that about 40% of their farms are now no-till, but still they are not free of chemical agriculture. But no-till is slowly becoming more prevalent. And when we plow for weeds, so weak weeds, the weeds which have which are less tough, they are easily destroyed. But the hardy ones, the tougher ones, they grow back again if their seeds remain, and because the competition is removed for them, they grow back again. So actually, other methods are required for de-weeding, or I mean, for taking control of care of weeds, but not plowing, because plowing does much more damage, other damages. Now, you can you guess what would synthetic chemicals that we put NPK and or DAP, ammonium nitrate, what will all these do to the soil? Nigat is saying there are certain crops where plowing becomes necessary, where it's with tractors or anything else, like rice. And as per my information, rice is staple crop of India. Do we have any other options other than plowing? Nikat, now there are people who are not plowing in the traditional way. They are even rice, they have started growing using other methods. Essentially, deep plowing is what we are talking against. So, I mean, if you dig a little and then put the seed in, that's not so harmful. But this deep plowing, that's very harmful. So even rice, wheat, etc., can be grown with no-till methods. So I'm going to quickly present one model, which which is a successful model of no-till. But first, I want to talk about synthetic chemicals. Okay, so Kavya is saying synthetic chemicals will not allow microbes to grow in the soil. Any other answer?
मैम उसकी ना सैलेंट जो पीएच लेवल होता है ना, उसको भी वो चेंज कर देते हैं, तो जिसकी वजह से जो माइक्रोब्स के लिए उनमें मतलब सरवाइव करना मुश्किल हो जाता है, और प्लांट्स के लिए भी.
Okay, so one answer Smriti gave is that pH can be changed, which is difficult for microbes to sustain. Any other answer? Nigat is saying it reduces fertility. So, I mean, you have to elaborate how or why they will reduce fertility, because after all, synthetic chemicals we are putting to increase fertility. We are putting nitrogen, phosphorus, potash, NPK are the primary ones.
मैम वो वाली जो फसल के लिए हम डाल रहे हैं, उस फसल के लिए तो वो अच्छा हो सकता है, लेकिन जो बाद वाली फसल होगी उसके लिए सॉइल को थोड़ा सा वो ठीक नहीं होगी, मतलब उसकी फर्टिलिटी को वो कम कर देगी.
Okay, so Smriti is saying for that particular crop it may be good, but not general fertility. But if any of you are saying it will reduce fertility, you have to tell me how. Kavya is saying mixes with natural minerals and may give some compound substance. Nigat is saying on continuous use because soil becomes dependent. And Menika is saying synthetic chemicals do not retain nutrients as much. But synthetic chemicals themselves are nutrients. See, synthetic chemicals, the fertilizers that we put are nutrients. NPK. Primary ones are NPK. Of course, there are like now some more coming in as solutions. Redmi is saying it can reduce the organic compounds in the soil. Kavya is saying soil will lose its capacity to retain its natural fertility. Tanvira is saying soil acidification. Menka is saying pH changes. Okay. So friends, like your answers are kind of close to the main answer, but
हाँ मैम,
artificial
एक चीज
chem-
और बोलनी है मुझे कि जब हमें तुरंत उसका इफेक्ट दिख जाता है कि हमारी फसल प्रोडक्शन ज्यादा आ रहा है फर्स्ट उसमें, तो हम ये भूल जाते हैं कि जो हमारा जो ह्यूमस कंटेंट के बारे में हम कुछ सोचते नहीं है, तो वो हम ऐसे प्रोवाइड नहीं करते, और फिर वो इस तरीके से उसमें वो जो ह्यूमस कंटेंट है वो लगातार कम होता जाता है, तो उसकी पोरोसिटी लगातार कम होती जाती है। तो जो बस यही है।
Okay, so there are more answers. So Humaira has said, said it will affect human health. Rakesh has said they will work like tonics. Kavya has said soil will be set only for particular crops, and Rakesh has said they are not supplements. And Smriti said we will not then give attention to humans because we are getting crops. So the first thing, see, so many of these answers are close to the actual answer. The actual answer is, firstly, microbial diversity is destroyed. See, soil can never become completely free of microbes easily. I mean, unless you really use a sterilization process by heating or maybe some disinfectant or something, I don't know how you will sterilize soil completely. So removing all total microbes is not possible, but diversity is destroyed. Only some microbes will flourish, but others will die. Menka has said biological magnification. Menka, can you elaborate? What do you mean by biological magnification? Do you mean these chemicals accumulating in other living beings or in water bodies? Do you mean that?
I'm sorry, ma'am. I am in the mall. So only, ma'am, biological magnification is nothing but the chemicals progressively increased in each food chain. The human is topmost. So accumulation of chemical is very high. It parallelly affects the health of the humans for using chemicals continuously.
Yeah, correct. Yeah, you are right about biological magnification. Yeah, accumulation in food chain. But right now we were talking about how they will affect soil fertility. So,
Yes, ma'am.
so when we talk about soil fertility, one thing we see is firstly, sorry. How can I not share my screen is not getting shared, no? Can you see my screen?
मैम शेयर तो हो रही थी, अभी अभी चली गई।
अच्छा, हाँ अब हो रही है।
यस,
तो
हो रही है।
so firstly, some microbes will become extra active. It's almost like giving them steroid. They become extra excited, extra active. Some or many die. Of course, earthworms die. Earthworms and many creatures die. But some microbes become overactive. Of course, like many of you said, the pH changes. So it's either soil will become more acidic or more basic. And one important thing is these chemicals actually reduce soil carbon, because soil carbon actually starts getting destroyed by both factors. I mean, like with urea, some soil carbon actually starts breaking down into carbon dioxide, and or some microbes themselves also start reducing soil carbon. So I mean, the oxidation of soil carbon starts here. And that's why all chemical fed farms have progressively reducing humus and other kinds of soil carbon. That's why our fields are so badly depleted of soil organic carbon, a very vital ingredient. It's reducing very badly, and therefore its inherent natural fertility is also getting reduced. So if you put excess nitrogen fertilizers, then bacteria would rapidly degrade soil organic carbon, and it starts breaking up into carbon dioxide. So actually fields start giving off carbon dioxide, and vast quantities of it. I'll show you those quantities, but agriculture fields are giving out carbon dioxide in large quantities. Then secondly, this factor, we talked about nitrogen fixing bacteria. So if you have legumes and crops which fix nitrogen, then that nitrogen is added slowly. But if you put urea or DAP, I mean like ammonium nitrate or DAP, whatever, then that nitrogen is added suddenly. All urea is suddenly added. So plants can't take it so fast, can't utilize all of it suddenly. So they will take whatever they want, they need, but much of it gets washed away, which is one huge problem. So, I mean, our water bodies are all getting like this one, like you can see on the right, huge algal growth, which has its own problem, which leads to, it is called eutrophication, and which leads to dying of aquatic creatures. But plants can't utilize this urea fully, much of it is wasted. Whereas in natural methods of giving nitrogen, the nitrogen is given slowly by bacteria, so the plants can take easily. So here's another classic experiment. These experiments have now been replicated many, many times in the world, including in our country by PUSA and other institutions. This is like Albert Harvard's experiment, 3738. So he took 2 plots again, removed all soil, put fresh soil in one place, fresh soil with compost, in another fresh soil with only NPK. And there was a very stark difference. Like these were tea plants. So in one place, this is not the actual photos. I mean, actual photos I've just put from the net. But where it was compost, the growth was 10 inches, healthy leaves and roots were there. But when there was only NPK, the growth was 6 inches, leaves and roots both were pale and poor growth. So there was such a contrast. So Albert Harvard had already said long back that it will be compost which will lead to healthy plants, not NPK. But then the question arises, and here's another, experiment. This is like very famous research station in UK, Rothamsted. So they have seen over 132 years, from 1843 to 1975. They maintained fields with manure and fields with urea. So in manure fields, nitrogen has tripled in so many years. But in fields with urea, where urea is added every year, still nitrogen gets washed away. Nitrogen is not increasing. Natural nitrogen is not increasing. So if NPK is this bad, or adding directly urea or artificial fertilizer is this bad, then why did Green Revolution yield such results? See, after all, it was Green Revolution which brought, at that time, it was the beacon of hope. Everyone said, well, now, and our country became self-sufficient in grains because of Green Revolution. Like MS Swaminathan was the torchbearer, and for the Green Revolution, there was this scientist called Norman Borlaug. He was given the Nobel Prize and all that. I mean, if chemical fertilizers are not good, why did Green Revolution give such good results in the beginning? See, those results are not being maintained now. But initial years, there was like crops doubled or tripled crop yields.
मैम इसलिए क्योंकि उस समय पे हमारी जो सॉइल है ऑलरेडी बहुत ह्यूमस रिच रही होगी, और एनपीके ने आके एक ऐसे कैटलिस्ट की तरह काम कर दिया और लेकिन दूसरी बात वो कि हाइब्रिड वैरायटीज भी बनाई गई थी और बहुत सारी चीजें एक साथ करी गई थी.
So Smriti is saying that our soils must have been already rich, humus rich, and plus these NPK must have acted as catalysts, and a lot more hybrid seeds and all that. So many more things were done. Any other answers?
मैम जिस एरिया में की गई थी शायद वहां पे पानी की बहुत अच्छी अवेलेबिलिटी थी.
Smriti, please give a chance to others also to speak. Any other reasons? Nobody? So Nighat is also saying hybrid seeds were used. Any others? Okay. So so Smriti, now you can say.
जहाँ पे क्योंकि ये पंजाब के एरिया के आसपास ही कॉन्सेंट्रेटेड थी ग्रीन रिवॉल्यूशन, तो वहाँ पे पानी की सप्लाई बहुत बढ़िया थी, शायद वो नदियों के कारण. सो एक जो डाइल्यूशन बहुत अच्छे से हुआ होगा एनपीके वगैरह का, या जो भी निकल जाती होंगी आराम से, और फिर वापस फिर से जो अगर दोबारा हमें क्रॉप लेनी पड़ती होगी, तो ऐसा कुछ भी हो सकता है, मुझे अच्छे से मालूम नहीं है.
So Smriti is saying that in Punjab and all those areas where the Green Revolution actually gave its best results, there must have been lots of water to which uh, would have actually washed away some of these chemicals, uh, and then Nighat is saying presence of alluvial soils. So actually, it's a combination of. It is true that many factors, and the Green Revolution works on a full package. Package means there has to be these specialized seeds, so you can't do it with native or ordinary seeds. So hybrid seeds, special seeds requiring special inputs, so a special set of chemicals plus protection from pests. And so pesticides were also a part of this whole package. And also of course irrigation. So this kind of cropping cannot happen without good irrigation and good soil. So the thing is, already, like Smriti had already guessed it, there was already, soils were not so poor at that time. If soil has inherent fertility, then adding extra NPK gives it further boost, some boost. But if its fertility is good and then you add NPK, you put in good seed, you put in lot of water and you give it the best conditions, then initially there'll be, of course, good production. Rakesh Verma is saying nutritional value. Nutritional value, at least initially, wouldn't have been nutritional value of soil. We talk about nutritional value of crops, but yeah, soil must have had, I mean, at that time, the soil was already fertile because of past centuries of usage. See, all across the Orient, not only in our country, China, Japan, Thailand, all these countries, Korea. I mean, farmers had grown healthy crops using manure and animal wastes and so on, and for very dense populations for centuries without any decline in soil fertility. So that was the done thing, ordinary thing. It's only now that by consistent usage, now the soil fertility by adding of chemicals and with crops getting diseased. See, it's like if plants are unhealthy, they get diseases more. So diseased plants, and then adding more chemicals to kill diseases, to kill pests, to kill insects and all that. It's like it's uh, becomes progressively weaker and weaker and weaker soil over decades. The soil currently is very weak, and now that soil cannot produce. That soil cannot produce without huge addition of help. That if a soil is not fertile, then you have to put in NPK, etc., to somehow get a crop out of it, which is what today's farmer has to do. And then on top of that, the plants are diseased. They get diseased very easily. In fact, that's exactly something Albert Howard had said 100 years back. He said Indian farmers have nothing. They are so poor, but their plants are so healthy. These plants don't get diseased. It's in UK that he saw that their plants used to get diseased, but not Indian plants. He was very surprised. He said the West should learn from the Orient. And actually, what happened is just the opposite. We left our own methods and learned from the West. So Nighat is asking, in simple words, we have to minimize the use of NPK fertilizers, but ma'am, without, is it possible to produce food for this increasing population? Yes, yes, and yes. And people are actually doing it. And there are models, there are very good models in our country, even at some good scale. In fact, in the beginning of the session, I was mentioning that me and some of my friends, we are going to Andhra to see this huge model where 10,000 farmers have already switched to natural farming. I mean, not 10,000 have switched, 10,000 farmers have become teachers for other farmers because they switched to natural methods and they are teaching others. So in Andhra, a very big experiment is going on, but even in other states, in many areas, people are slowly realizing that the current model cannot go on. It's too dangerous, it's too damaging. Dangerous because it's poisonous, it's poisons for everyone. Poison in soil, poison in water, poison in food. Who would think of poison in food earlier? Just 100 years back. Poison in our food. Just think about it.
मैम बट श्रीलंका ने ऑर्गेनिक फार्मिंग अपनाई, सो उसकी इकोनॉमी का बहुत बुरा हाल हुआ। ये क्या सही बात है? केवल यही रीजन था या कुछ और भी रीजन थे? मालूम नहीं, मिक्स चीजें होंगी। तो मतलब ऐसी सिचुएशन भी लोग बोलते हैं कि ऐसा भी हो सकता है।
So Sri Lanka made a mistake and terrified the whole world. And that's the only reason given by everyone that Sri Lanka did not succeed, so it cannot succeed. But just think about it. Just 100 years back, the whole of the Orient was doing it, including Sri Lanka. We were doing it successfully. India was doing it successfully. If organic cannot work, why did it work for thousands of years across
मैम
half
कल
the
एक
world?
मैं इंटरव्यू सुन रही थी, तो उनका कहना था, वो भी एक फार्मर थे, बड़े फार्मर थे, और उनका कहना था मैं तो फार्मर, एक एंटरप्रेन्योर भी हूँ, लेकिन 100 साल, ये जो कारण दिया जाता है कि 100 साल पहले सारी दुनिया ऑर्गेनिक कर रही थी, लेकिन 100 साल पहले गरीबी भी बहुत थी और भारत को अमेरिका से गेहूं भी मंगाना पड़ा था। ये उनके रीजनिंग थी, मतलब। सो इस रीजनिंग को हम कैसे काउंटर करेंगे?
So you will have to first see. I don't have much time left. There are only 5 minutes formally left. How many of you can stay? Because I need to like in short, I'll present this model. The model
Okay.
that has functions well. And actually, see, today my job was primarily to talk about soil fertility, which I have tried. But I do want to give the other model, and it has answers to all these questions. See, it's not like it's only now proponents of chemical fertilizers and pesticides and those firms, those people who want that fertilizers should stay, pesticides should stay, they are promoting this kind of thinking that no, organic will not succeed, organic cannot succeed. See, India was poor because of other reasons, Smriti. For like 2.5 centuries, we had been looted very badly. We had been looted very badly. We had been decimated. We had been impoverished. We had Bengal famine and all that. Do you think it was because of poor soils or farmers being stupid? I mean, how can we forget all historical, economic, sociological factors and political factors and actually say that no, our farmers did not know how to grow food. In fact, India's poor farmers, those poor farmers who had nothing in the name of any support from anywhere, they grew crops, they grew seeds, they grew their own, they had their own sources of manure, and they kept cattle, and there was such a good like marriage between animal husbandry and agriculture, and all has been destroyed. And what is happening today? Do you think our farmers actually having a very great deal? Our farmers are committing suicide in large numbers. Our farmers are under debt. And actually, if one totals the total inputs in agriculture, the farmer is actually in loss. The point is because nobody totals it properly. So I know of somebody who must have sat with at least 15,000 farmers, and he says when they do this total inputs, including labor, including everything, they are not making much. They are substituting or supplementing their farm income with so many other things. But anyway, let me at least come to uh, this whole thing. So if low fertility is there, then fertilizers have to be pumped to give it basic fertility. And basic fertility keeps dropping. So fertility keeps dropping, you have to keep adding more fertilizers. So there are various ways to add microbes, and these are microbial cultures. There are many, there are at least 20. Amrit Jal, Jeevamrit, Panchgavya, vermicompost, manure. You will hear a lot of these names, and there are proponents of each. It doesn't matter. These are microbial cultures. So these are ways to increase microbes. But even if you increase microbe, but do not increase organic carbon, your farming will still not be good. Unless you increase carbon, all this alone will not work. Therefore, you have to think of all the things, and the model I'm presenting is Mr. Patanjali Jha's, but there are many successful models. So I'll quickly say that this model concentrates on these three things: increasing microbes, increasing natural nitrogen, and increasing carbon. So for these, what is done is soil organic matter is built very consciously. So lot of organic matter is added to the soil, which means all sorts of fallen leaves and mulch and grass, and I mean any organic matter available is spread on the soil. Crops are rotated. Somebody is writing on. So crops are rotated and multi-cropping is done. So nature is always biodiverse. So the more biodiverse you are, the healthier your soil is, the healthier your microbes are. So diverse, because diverse organic matter comes. So crops are rotated and multi-cropping is done. Tilling is not done so that the soil fungal network is not broken. Fungal and microbial network is not destroyed. Then lot of mulch is added. Mulch is an essential thing. Soil is never left bare, never. So this keeps it moist and healthy, doesn't allow it to dry, so no erosion happens, no damage to soil creatures. So dry leaves, crop residue, prali, everything is utilized. So, and this is just sprinkled with dung slurry. Just cow dung is made into a thin slurry and sprinkled. No separate composting. Composting is not necessary because all of your soil becomes like compost. So this way, animal dung and nitrogen compounds are added. Microbial activity happens by itself. Multi-layered farming is done. So combination of trees, bushes, and herbs, and underground also, like haldi and those tubers are grown. So they are like creepers and climbers, and so the sunlight is utilized. It's called a food forest. So sunlight is utilized very efficiently. Pulses, legumes are always sown alongside at least once in a year to keep natural nitrogen. in the soil, and then efficient plants which build soil carbon. So in which this vetiver or khas grass is a very efficient plant. So at least in this farm, they have kept it all along with other plants, because it builds um, with this very rich root system and very fast growth. It builds carbon, it gives a lot of biomass, builds soil carbon, increases soil water retention and soil microbial activity. So that it's all kept, and it's constantly cut. So they cut and either use it as fodder or use it as mulch. Then some very efficient trees like Moringa, Agastya, so trees that support other trees. Moringa is extremely carbon efficient. It builds 20 times more carbon than other trees. 20 times. Just let that sink.
मतलब कैसे मोरिंगा कैसे कार्बन बना लेता है ज्यादा?
इसका रीजन मुझे नहीं पता है. I don't know
अच्छा,
the reason why Moringa builds more carbon, but there have been studies. Like
Okay.
there are, like if you give a general search on the net, you will find Japanese studies on how Moringa builds soil carbon 20 times more than, let's say, Devdar trees. They have compared to those hill trees, and they've said it's like so much carbon is built. So weed control is done with the help of mulching, aggressive mulching. So the ground, like this is a crop plant, so the ground is completely covered with mulch, or a nitrogen fixer is grown in between crops, and even weeds are chopped and spread as mulch. So that's one method. Otherwise, like one method which I haven't mentioned here is like giving uh, the crop plant advantage, the competitive advantage. Sow its seed earlier before you cut the first crop, one season's crop. Before you cut it, before you harvest, you put the seed before that, 2 weeks before that. The next seed you put before that. So give it advantage, give it a head start. So that's another method used. And this way, very, very poor, very pathetic soils can be regenerated. Now they have very healthy food forests. So the model that and now I need to end. So I'm just like how this whole thing will save our earth, our heating up globe. So I'll just talk about atmospheric carbon dioxide before agriculture was 220 ppm. Current it's 420. So it's not 220, 200, and now it's 420, more than double. Out of which a large amount has come from agriculture over past 10,000 years. And soils have the capacity to hold 4 times more carbon than the atmosphere can hold. I mean, any carbon dioxide that is absorbed by plants 4 times goes to the soil, can go to the soil. Only 20% stays above. So if we let soil absorb more carbon, soil is the second largest carbon sink after ocean. So if we let that happen, I mean, I'm just giving these two. So even currently, there's 1550 gigaton of organic carbon in soil in the world. But there is, and in the atmosphere, there is 780 gigaton. So already there is much more carbon in the soil, but this has the capacity to absorb far more. And also in past 10,000 years, carbon has increased in atmosphere from 360 to 780. So much of this has come from changing land use, from deforestation, from agriculture and all that. And this is the surprise. Land has emitted 575 gigatons of carbon, which is surpassing 445 gigaton the emissions from fossil fuels. We think of fossil fuels as the only culprits, but it's our soils giving off carbon, soils giving off carbon dioxide. So if we have to, we can, I mean, if we become aware of this, we can return back to soil, which should go back, leaves, biomass. Instead of gardens like these, we can have gardens like these, which is happening, which has already started happening in the world. I mean, like this trend has started, but more people need to become aware. The more humus we increase, the more water we'll absorb, the more rainwater harvesting we'll do, the more groundwater we'll have. Instead of monocultures like these, we should have gardens or rather fields like these. So this, as consumers, we should seek healthy and nutritious food. We don't have to poison ourselves. We don't have to poison the world around us. And this is the last thing I want to say for today. A time has come when treating the abundance of Mother Nature as sacred is the only path left for survival. Anything else, I mean, we consider a lot of things sacred, but we have to now look at nature and soil as sacred. It is abundant. Nature gives so much if we allow it to give. If we snatch its vitality, we'll kill it, but we'll kill ourselves also. So with that, I want to end for today. If you have to say anything, please add. Nikhad has said Sikkim is the first organic state. See, now, by now, like with organic methods, but see, this is not only organic. The model I was presenting, it's not only just replacing chemicals. There's more we'll need to do. Like sensible utilization of water, growing biodiverse crops, like mixture of crops, not keeping soil ever dry or barren. We have to cover it with mulch, like utilization of all the crop waste. We'll have to make more decisions which are soil friendly or earth friendly. If we do that, such farms actually produce more than, it takes some time, 1 or 2 years it takes to come back, but even within first years they come at par with chemical fed farms, and within 1 or 2 years their output increases. So that's what, like, people have actually shown this and proved this. It's only that, like, we should see the damage which is being done, the costs. There are costs in terms of health also. There are costs in terms of poisoning also. There are other costs. Those costs we are paying in any case in the name of good yield. So all that, but even in terms of just pure productivity, if we reverse these trends and restore soil fertility, we can bring back health to our soils, we can bring back health to ourselves, and we can bring health to the planet. See, all that is possible through a very, very, very positive and benevolent method, by destroying nothing other than maybe corporates who are selling poisons. They are probably the ones who will get damaged. Otherwise, destroying nothing, we can restore health. And that's the whole message of this session. That's the whole message I want you to take away from here. Welcome, Nigat. I hope, I mean, science teachers, I keep saying science teachers have a great responsibility today. Because it's only science teachers amongst the general public. Science teachers understand science. And if we understand this, we should now realize what is the science that will empower all of us. If we take it further, we take it to lay people, ordinary people, and we do our job of taking the positive message of science, we can actually bring a change. We can be change makers. Thank you, Fozia. Thank you, Jara. Thanks, everyone. So I will